welcome to Unit 1, Lesson number 5. Today's lesson, we're going to be talking about removing discontinuities. So in the previous lesson, you used limits to define continuity on open and closed intervals, and you also looked at different applications of the intermediate value theorem. I know last lesson was a rather longer lesson. This one is going to be much shorter. So in this lesson, we're going to be using our knowledge of functions in algebra to remove discontinuities that may exist in functions. So example number 1, we want to find a constant value a such that the function is continuous on the entire real number line. In other words, if we look at this graph, we'll notice that the coefficient of the bottom part of the piecewise function a will have an effect on where that graph lines up. We want to find a value of a so that the two pieces come together. In other words, we want the limit from the right to equal the limit from the left. So at 2, which is where the piecewise function is broken into two pieces, we want the value for a to equal 8. So that's going to yield an answer of a is being equal to 2. And that's my answer. In this next example, very similar, find the constant b such that the function is continuous on the entire real number line. Again, we have a piecewise function made of two pieces, and those pieces are divided at x equals 2. So what we want to look at first is what's going on at 2. And ultimately, we want the limit from the left to be equal to the limit from the right. So plugging in 2 to both pieces is going to give us an equation of 4 plus b squared is equal to 4b, which is a quadratic equation. And so relying on our algebra skills, we're able to solve the quadratic equation in this case by factoring, giving me an answer of b being equal to 2. Notice that for any other value of b, that equation is not going to be equal, and therefore, moving in sort of a reverse manner, the limit from the left and the limit from the right won't be equal, which would make the function not continuous. So in quick summary, a function can be made to be continuous by ensuring that the limit from the left is equal to the limit from the right.